The 2018 higher level question asks us to calculate the U value of an uninsulated ground floor, the heat loss associated with it, and how to bring it up to modern living standards with passive. To start off question A, part A, I divided a sheet 170mm across into 50, 30, 30 and 30 and divided around a third of the way down my sheet. I then broke it up into conductivity, resistivity, thickness and resistance. Conductivity is a symbol of K, resistivity is a symbol of R, thickness is measured in meters and resistance is a large R. I then inputted all the elements along the left hand side: internal surface resistance, screed, concrete subfloor, radon barrier, sand blinding, hard core and subfloor. Each of these has a unit associated with them. The easiest one to first of all input is the capital R, which is resistance. That's the resistance of the internal air resisting heat going down into the ground. All other elements have an associated number with them. These are either a conductivity value or a resistivity value. These can be found in the thermal data, whether it's a small r or a k. These are inputted into the appropriate columns. All measurements given in the question are in millimeters, but for the purpose of the formula to work must be converted to meters. This is done by dividing it by 1000. In the radon barrier, it is 0.25 of a millimeter, which is 1/4 of a millimeter in thickness because it's only a sheet of plastic. To get it to a meter, I divide it by 1000, but it's coming up as a scientific fraction. A little trick here is to add 1 to make it into a decimal point, so then I cancel the 1 off and it becomes 0.00025. Both of these formulas need to be known for the purpose of the exam, and depending on whether I'm dealing with conductivity or resistivity decides which formula I use. All the resistances are added together to give me a total resistance. Be careful when inputting them into the calculator not to make a mistake. My U value formula is 1 over the total resistance, which in this case is 1 over 0.8042. This will give me a U value. The U value is measured in watts per meter squared degrees Celsius. All formulas on the day of the exam are worth marks, so make sure to input them in the correct places. Part B of the question asked me to calculate the cost of heat loss through this uninsulated concrete ground floor. The formula on the day of the exam must be learnt off. It's U value multiplied by area, multiplied by the temperature difference between inside and outside, multiplied by the time that the heat is on for, multiplied by the cost, divided by the calorific value of oil, multiplied by 1000. This formula must be remembered for the exam. What also is important is the area is in meters squared, temperature is in degrees, time must be in seconds and cost must be in euros. The last two there are the hardest to remember: time in seconds and cost in euro. All the data that's needed to input into this formula is given in the question. The U value we've calculated in part A, the area is the size of the room, temperature difference between outside and inside is 16 degrees, and the time must be calculated in seconds, which is 60 seconds for 60 minutes, for the 10 hours a day that it's on, for the 7 days a week, and for the number of weeks, which is 38 in the year that the heat is on for. Because we are doing the shortened version of this formula, it is very important that all workings are shown, because in the event an incorrect answer is given, marks are awarded for showing your work. Make sure you write it out, put it in brackets, and input it into your calculator very carefully. The answer here is that €352 is lost in money terms through the floor each year. Part C of this question wants us to redo this floor to bring it up to passive house standard, which means that the new value of the floor is going to become 0.15. That is a huge difference in a U value, therefore a lot of insulation is going to be required in the floor. We are asked what thickness of insulation would be required in a new floor if we were to redo this house. The conductivity of the new insulation is 0.037. The old floor has a U value calculated previously. The new floor has a U value of 0.15. The difference between the old floor and the new floor is substantial, as we can see here in the question. We must work our way backwards into the formula to be able to find the resistance. You can calculate the reverse of the U value, which is the resistance, by dividing it by 1. So in this case, 1 divided by 1.2434 brings us back to the resistance that we calculated in part A. And when we calculate the resistance of the new floor, it gives 6.666. The resistance is useful now for our formulas. What is the difference between both? Well, what has changed? What really has changed here is that we've added insulation between the new floor and the old floor. Therefore, the difference in the resistance is actually the resistance of the insulation, because that is what has changed between the new floor and the old floor. I set about drawing a quick table because this will make it very clear what the thickness of the insulation is. I start inputting in all the data that I know. I know that the conductivity of the insulation is 0.037 because it's given in the question. I also should know the resistance of the insulation because I subtracted the resistance of the old floor and the new floor. That is given as 5.862. I don't know what X is, and R in this case, which is resistivity, is redundant. We don't need it in the question. I know a formula for calculating resistance is R is equal to T over K. I manipulate that formula to turn the T opposite the opposite side of the equal sign. Therefore, the formula that I'm going to use today is T is equal to R multiplied by K. When I work through the formula, I find that 217 millimeters of insulation is required to bring this floor up to passive house standards.